In this video, you will learn how to implement a real-time chat application using Spring Boot WebSockets and DragonflyDB. We'll start off the video by understanding the basics of WebSocket and what are the advantages of using WebSocket for the real-time applications. And then we will discuss about DragonflyDB. We'll learn about what is DragonflyDB, why we want to use DragonflyDB, and what are the advantages of using DragonflyDB. And then we'll go ahead and dive in to develop this real-world chat application using Spring Boot WebSockets and DragonflyDB. So without any further delay, let's start the video. So first of all, let's see a demo of the chat application we are going to build. So you can see these three windows on my screen. So what I did is I am running the chat application in multiple instances. So there are two instances of my application running on port 8080 and port 8081. You can see that for port 8080 there is one chat client connected through the browser, and there are two browser clients connected to the server running on 8081. So first of all, I'm going to join this chat with the username user1. So I'm going to click on the button start chatting, and you can see that there is a very simple chat interface here with the text area and the send button and the text area to show the chat messages. So this is for the client 1, and for client 2 I'm going to add a username as user2, and I'm going to start the chatting. And you can see that we are also able to see the message user1 joined the chat and user2 joined the chat. So these are the status messages for each chat operation. So on the third browser, I'm going to add the username as user3, and I'm going to start chatting. So I'm going to come to the first client, and I'm going to type a message, "Hi everyone." And you can see that this message is broadcasted to the remaining clients. The message "Hi everyone" is also visible for the user3 and user2. So now let's type a message from user2, "Hello all," and likewise we see the message "Hello all" broadcasted to all the clients. And finally I'm going to send a message like "Hey guys." So you can see that this message is also broadcasted across all the clients. So what I'm going to do now, I'm going to close this user3 session, and you can see that the user3 left the chat. We see the message user3 left the chat because the client connection from user3 to the server is disconnected. So that's why we are able to see the disconnection message here. So if I also disconnect the user2's chat session, you can also see the message user2 left the chat and user1 is the only one remaining in the chat room. This is the demo of the chat application we are going to build using Spring Boot WebSockets and DragonflyDB. Alright, so now let's start by understanding what is WebSocket communication. So WebSocket is nothing but a communication protocol that is very similar to HTTP, which supports bidirectional communication. So what do you mean by bidirectional communication? So here you can see that in a standard HTTP request response model, whenever the client wants to send some data to server, first of all, the HTTP connection, the TCP connection is established, and after the TCP handshake, the client will send the request to the server, and the server receives this request and then responds with a response. Once this response is received by the client, the connection will be terminated, and if at all the client wants to send another request to the server, it has to establish a new connection and start the communication all over again. So as you can see, this is a single way direction communication, so it's not a bidirectional communication. Whereas in WebSockets, what happens is once the client establishes the connection with the server, the client can send messages to server and the server can send messages to the client at the same time. That means in real time. So this is not possible using HTTP communication model. So that's why people use WebSockets whenever we want to implement any real-time applications like chat applications or something like that are based using WebSockets. Another important thing to remember is WebSockets use persistence connections. That means once the connection is established, it is alive until the client or server closes it explicitly. Whereas in HTTP communication, the connection is terminated once the response is sent from server to the client. So let's look at some high-level architecture of our chat application. So here you can see that we have one server and multiple clients that use WebSocket communication that interact with the server. And this is usually how a group chat application looks like, right? There are multiple clients that wants to listen messages from a server, and whenever a client is sending a message, this message is replicated instantly to different clients by the server. This is the high level architecture. But if we look, if you want to make this scalable, of course, you need to run multiple instances of the server. So in this case, we can have a problem that some clients will be connected to one server and some other set of clients are connected to another server, right? So like the example you see on the screen, you can see that client 1, client 2, 3, and 8 are connected to server 1, and client 4, 5, 6, 7 are connected to server 2. So in this case, what happens is, if a client 1 is sending a message, this message will be broadcasted to all the clients 1, 2, 3, 8, but this will not be broadcasted to 7, 6, 5, 4, because the message is communicated to server 1, but the message is not known to server 2, right? So this is one kind of drawback we can have in our group chat application. So to fix that, what we can do is we can use some kind of publish subscribe mechanism, so that whenever server 1 is receiving a message, it is replicated to server 2, and the server 2, once it receives the message, it broadcast it to its own set of clients. So in this case, it would be 4, 5, 6, 7. So if I just scroll down, this is how the target architecture will look like. So in this case, the client 1 and client 3 are communicating to server 1, and whenever a message is sent from client 1 and client 3 to server 1, this message is replicated to server 2 using a publish subscribe mechanism. We'll be using DragonflyDB to implement this functionality, and once the message is received in server 2, this is broadcasted instantly to client 2 and client 4 using the WebSocket mechanism. So this brings us to the question, what is DragonflyDB? So DragonflyDB is an in-memory data store that is lightning fast and is designed as an alternative to Redis. So it's fully compatible with the Redis API. That means you can use it as a drop-in replacement without changing your existing application code. So the main interesting feature about DragonflyDB is its massive scalability. It optimizes memory usage by taking advantage of modern multi-core CPUs and delivers significantly higher throughput and lower latencies than Redis in many of the scenarios. Here you can see in the homepage, there is benchmarking displayed regarding the throughput in queries per second. For set, get, and setx operation, you can see that DragonflyDB is significantly outperforming Redis. So as I mentioned before, it is a drop-in replacement to Redis. That means it supports all familiar Redis data structures like strings, lists, sets, and sorted sets. If you're dealing with performance bottlenecks or performance problems or scaling issues with Redis, DragonflyDB is designed to handle these challenges more efficiently, because it supports multi-threading compared to Redis, which is only single-threaded, and it also offers better performance without increasing any complexity. So in our application, we'll be using DragonflyDB as a queue to help us provide scalability for our group chat application. So now let's go ahead and start coding our application. So I'm on the website start.spring.io. Let's create the starter files for our chat application. Here I'm going to select the Maven project with the language as Java, and the Spring Boot version, the latest Spring Boot version at the time of recording this video is 3.3.4. I'm going to select this version. The group ID, I'm going to add it as com.programming.techie, and the artifact ID is going to be chat app, and I'm going to create a package with the same name, com.programming.techie chat app. I'm going to use Java 21, and coming to the dependencies, I'm going to click on add dependencies, and I'm going to add the dependency to add the WebSocket support. We are also going to add the support for Redis. So here I'm going to select the Spring Data Redis project to add the Redis APIs for us. Remember that DragonflyDB is a drop-in replacement to Redis. You don't need to add a separate DragonflyDB API to your Spring Boot project. You can just use the existing Spring Data Redis libraries, and DragonflyDB will support very good out-of-the-box functionality for those APIs. So I'm going to select the Spring Data Redis project here. I'm also going to add the dependency for Lombok. And finally, for the chat application UI, I'm going to use Timeleaf. I'm going to add the Timeleaf dependency, and once this is done, I'm going to click on generate, and this will download the starter project to my machine. Let's go ahead and open that project in your favorite IDE. I'm going to open this in IntelliJ. After opening the application in your favorite IDE, so the first thing I'm going to do is go through the project structure. You can see that we have a pom.xml file where the version of the Spring Boot starter parent is 3.3.4, and we have some dependencies. We selected, of course, the Spring Boot starter data Redis dependency, Spring Boot starter time leaf, and Spring Boot starter WebSocket. We have the usual Maven structure, source main Java, and inside that we have our main application, the chat application, which is annotated with the Spring Boot application annotation. The first thing we are going to do here is to create a WebSocket configuration for our application. So for that, I'm going to right click on the root package, and I'm going to create a new class. And this class I'm going to create under a package called as config, and the name of the class is going to be WebSocket config. And on top of this class, I'm going to add configuration annotation, as this is holding the WebSocket configuration. I'm going to also add the annotation enable WebSocket message broker. So Spring Boot uses a message broker to implement WebSocket functionalities. So if you go inside this enable WebSocket message broker annotation and download the sources, you can read the description to add this annotation to enable broker-backed messaging over WebSocket using a higher level messaging sub protocol. So you need to add this annotation to enable this WebSocket communication through a message broker. And you can also see the sample example of how configuration usually looks like. We need to implement an interface called as WebSocket message broker configurer, and then this will allow us to override some methods where we can configure the WebSocket configuration, where we can provide the more details about our WebSocket configuration. So let's go ahead and do that. I'm going to go back to the WebSocket config class, and here I'm going to implement WebSocket message broker configurer. And I'm going to go to this example, and I'm just going to make my life easier by just copying this example from the documentation, and I'm going to just come here and paste this inside the class. So as you can see here, so let me first import this stomp endpoint registry class. I'm going to click on import, and the same thing for message broker registry. I'm going to click on press import class, and here you can see that we are overriding two methods. First one is register stomp endpoints, and the second method is configure message broker. So for the configure message broker, we are going to take in object of message broker registry, and using this message broker registry, we are going to set some metadata like set application destination prefixes. We are going to set it as /app. So this is something like an endpoint where our application is where this message broker is available. And coming to this enable stomp broker relay, we don't need this method. What we really need is enable simple broker. So we are just going to make use of a simple message broker to enable WebSocket communication, and the message broker should be available under the destination /topic/public. So this is the message broker destination where WebSocket is listening to the messages. So after adding this configuration, we will also configure the register stomp endpoints. Stomp is nothing but a communication protocol that is used by message brokers to send messages between the broker and the client, right? So we are using an object called as stomp endpoint registry, and using this stomp endpoint registry, we are going to add an endpoint called as /chat_app, and we are going to enable this endpoint using the sock.js functionality. This is again another library that enables WebSocket communication. After adding this configuration, the next step is to create a controller that handles the incoming request to the chat application. So I'm going to right click on the root package, and I'm going to create a new Java class under a package called as controller, and I'm going to call this class as chat controller class. And here I'm going to add the controller annotation on top of the class. Just note that we are using a controller annotation but not REST controller, as you may have used very frequently while developing Spring Boot applications, because this WebSocket application is not a REST-based application. So that's why we just use controller annotation from Spring Boot. And inside this class, we are going to define two methods. One method is to send message to the clients, and another method is to add user to the application. When in the demo project, you saw that whenever a user is entering into the chat room, we are displaying a broadcast message that user 1 or user 2 has joined the chat and then left the chat, right? So for this functionality, to implement this functionality, we need to add a method to add a user to the WebSocket session. And when that particular user is sending out a message, we need to also handle that request by creating an endpoint. It will send this message back to the different clients. First of all, we will implement the method to send the message back to the clients. So to implement this endpoint, we are going to make use of the message mapping annotation that will enable a handler for the URL to send a message. So I'm going to add this message mapping value as /chat/chat.send, and here I'm going to define a method called as public, and this method will return a type called as chat message. We will shortly create this class for chat message, and the name of this method is going to be send chat message, and this endpoint is going to take, and this method contains the parameter called chat message, and we need to add a payload annotation because this chat message is coming in as a payload from the client. So let's go ahead and create this class under the DTO package. For this class, I'm going to add data annotation from Lombok, and I'm going to add allogs and noargs constructor. And inside this class, I'm going to I'm going to define 4 fields. The first field is going to be the message typed in by the user, and the next one is going to be the timestamp at which the user is generated the message, typed the message. The fourth field is going to be username, and the fourth field is going to be enum called as message type. So I'm going to create this enum. This is not yet existing, so I'm going to choose the option create enum message type under the DTO package. And this message type can be of 3 types. So it can be a chat message, it can be a status message like user joined, or status message like user joined the chat, and another status message that the user has left the chat. So let's go back to the chat message class, and here we have configured everything fine in the chat message class. Let's go back to the chat controller, and let's continue adding this logic inside this method. So inside this send chat message, the first thing we have to do is to set the timestamp when we received this message. So to set the timestamp, I'm going to use I'm going to add chat message dot set timestamp, and here I'm going to type in local date time dot now dot format date time formatter dot ISO local date time. So this will make sure that it will take the local date time and format it it according to the ISO standard, and it will set the value in the timestamp field. So after receiving this message, what we have to do is we have to send this message onto our DragonflyDB queue. So if you go back to the diagram, you can see that whenever a client is sending a message to the server is sending this message to the queue, to the DragonflyDB queue, and the other server will be listening to this message and will be broadcasting this message to these clients. So we implemented the endpoint to listen to this messages. So let's go ahead and do that. So I'm going to go back to the chat controller, and in here we need to add some logic to send message to DragonflyDB DB queue. So before adding this, we need to also add this Redis configuration in our application. So I'm going to go to the config package and I'm going to create a new Java class called as Redis config. So again, as we are using Spring Data Redis library, I'm calling this class as Redis config. But remember that DragonflyDB is fully compatible with Redis, and in the background, our application will be talking to the DragonflyDB, which is running on the Docker Compose. And inside this Redis config class, we need to first define a bean called as Redis template that will help us to send message to the Redis queue. So for that, I'm going to add the bean annotation, and I'm going to type in public Redis template. And this Redis template is going to take in some generic arguments. I'm going to make use of string as a key and object as the value to make it generic. And I'm going to name this bean as Redis template. And this Redis template bean takes in a parameter called as Redis connection factory. And inside this Redis template bean, I'm going to create Redis template object with key generic, with key as string and object as and value as object. And I'm going to call the variable as template, and I'm going to create a new Redis template. And to this new Redis template, I'm going to set the connection factory as Redis connection factory. And the next thing we have to do is we have to set a serializer and the key serializer and the value serializer, so that the Redis template will understand how to serialize this particular key and value. So for that, I'm going to add a template.setKeySerializer as new string Redis serializer. And for the value serializer, I'm going to use the set value serializer, and here I'm going to add new Jackson to JSON Redis serializer. So we need this Jackson to JSON Redis serializer because we are using an object as a value, and we can have any kind of JSON object. For that reason, we are providing the Jackson to JSON Redis serializer here. So after adding this configuration, I'm just going to return this template to complete the bean creation process. And not only this, after adding this bean, we need to add some more methods. So the next one is going to define a topic, because as we are using as DragonflyDB as a queue, we need to also create a channel topic to where DragonflyDB listens to this messages for this particular topic, and then the other servers can subscribe to this topic, right? So I'm going to add the bean annotation, and I'm going to type in public channel topic, and I'm going to name this bean as channel topic. And here I'm going to return new channel topic, and the name of this topic is going to be chat, right? So this will create a channel called as chat inside our DragonflyDB. For now, we are done with this Redis configuration. So now let's go back to the chat controller, and in here what we'll do now is we'll inject the Redis template bean we created in the Redis config class into this chat controller class. So for that, I'm going to type in private final Redis template, and I'm going to add the required args constructor to make sure that this Redis template bean is injected into the chat controller class. And inside the send chat message, I'm just going to remove this comment, and I'm going to type in Redis template dot convert and send. I'm going to send this message to the channel called as chat, and I'm going to just send the chat message over to this particular channel. And once this is done, I'm going to just return this chat message back to the client, right? So again, in a nutshell, what this particular method is doing is it is exposing an endpoint called as chat.send, so that the clients can call this particular endpoint and send out a chat message. And inside this chat message inside this method, we are setting a timestamp to register the time at which this message is generated. And then we are sending out this message to DragonflyDB queue, where other instances of the servers can subscribe to this particular topic or channel, you can say, and then it will read this particular message and broadcast it to the different servers. This is what is happening in this particular method. Now, so for now, we created the part where we are publishing the message to the topic, but we also need to add the logic where the server will subscribe to this topic and then listen to the messages and broadcast it to the clients, right? So now let's go ahead and do that. I'm going to go back to the Redis config class. Again, as I mentioned before, I'm calling this class as Redis config as we are using Redis libraries from Spring Boot. But remember that DragonflyDB is fully compatible with Redis, and all these libraries and the code we are writing will be actually talking to the DragonflyDB running on our local Docker instance. And in here, what I need to do is we need to create a Redis message listener container bean. So that will create a configuration to create the listener for this particular channel we created. So for that, I'm going to add a bean annotation, and I'm going to type in public Redis message listener container, and the name of the bean is going to be Redis message listener container. And this bean is going to take in the Redis connection factory as the parameter, borrowed by another class called as message listener adapter. After adding these two parameters, what I'm going to do now here is I'm going to create an object of type Redis message listener. So I'm going to type in Redis message listener container, and I'm going to call this as container equals new Redis message listener container. And to this container, I'm going to set the connection factory as Redis connection factory. Container.add message listener as message listener adapter, and this method also takes in the reference to the topic for which we need to create a listener. That is going to be the channel topic bean. So we are just going to provide a reference to the channel topic method here inside this configuration class. And finally, we're going to type in return container to complete the bean creation process, right? So one thing you may have observed is IntelliJ is complaining that it could not auto-wire this particular object because there is no beans of message listener adapter type found, right? So to fix this issue, we need to create a bean of type message listener adapter, and here I'm going to type in a class called as Redis message subscriber. So this is going to be the class we will be creating. So this will be the listener, actual listener that will listen to the incoming messages from the channel and then send this message back to the clients, right? So I'm going to create this class called as Redis message subscriber under a package called as listener, and this message subscriber is going to implement an interface called as message listener. And you can see that now IntelliJ is asking us to implement this method called as onMessage. So what this message will do is whenever a message is received to the chat topic, so this onMessage method will be called with this particular method, will be called, and then we can have the logic to broadcast the message to the clients. Let's go ahead and implement this logic here. Inside the onMessage method, I'm going to first deserialize this message into the chat message object. So for that, I need access to the Redis template inside this Redis message subscriber class. So I'm going to first auto-wire the Redis template object here. So for that, I'm going to first define this Redis message subscriber as a component, and I'm going to add the required args constructor from Lombok. And inside the class, I'm going to type in private final Redis template, which is taking the key as string and value as an object, generic argument. And I'm going to define this as Redis template. I also need access to the object mapper from Jackson library to make sure that after deserializing this message, I need to convert it to the chat message object. And after defining object mapper, I need to define another dependency here. So I'm going to type in private final SIMP message sending operations. So this class is coming from the Spring Messaging SIMP package. So we need this object to send the message back, to broadcast this message to the clients, right? So I'm going to copy this Redis template reference, and I'm going to type in inside the onMessage method Redis template dot get string serializer dot deserialize message.getBody. So the body of the message is of the return type byte array. So we are going to first deserialize this byte array into a string. So I'm going to type in string published message equals the deserialization, the return type from the deserialize method. And the next part is to convert this string to chat message. So for that, I'm going to make use of object mapper dot read value, and I'm going to pass in the published message here, and the return type is going to be chat message dot class. So with this, the object mapper will convert this string to the chat message object. If there are any errors, of course it's throwing an exception, because if there are any errors, it has to handle the error handling will kick in. So for now, I'm just going to select this option surround with try catch, and I'm throwing a runtime exception for catching this JSON processing exception. And let's store this return value from read value method in a new local variable called as chat message. And this chat message object, I'm going to send this to the clients using this SIMP message sending operations dot convert and send. And I'm going to select this method where I have to provide the destination and the object payload. So for the destination, I'm going to use the destination topic as /topic/public, and the object is going to be chat message. So this is how we have to define the listener. Then the listener will read the message, convert it to the chat message object, and then send it back to the clients. So I think we have an error in the Redis config. So let's go back and complete the bean configuration for message listener adapter. So here inside, I'm going to type in return new message listener adapter, and I'm going to simply pass in this Redis message subscriber, and that's what we need to do to create a bean for this message listener adapter, right? We inject this Redis message subscriber and then wrap this and pass this as a constructor argument for the message listener adapter. We have to do this because the message listener adapter is the superclass, and we have to pass in the object as a delegate to this construct. All right, so that completes the Redis configuration. And the next thing we are going to do is, of course, to download DragonflyDB into our database, into our local machine. So I'm going to make use of Docker Compose here to download DragonflyDB. So for that, I'm going to select the folder of the project, and I'm going to right click new file, Docker Compose.yaml. And in here, we are going to define the service for DragonflyDB. So I'm going to type in first services, and under services, I'm going to add the key as DragonflyDB. And inside the DragonflyDB service, I'm going to first define the image docker.dragonflydb.io/dragonflydb/dragonfly. So this is the URL where you can download the DragonflyDB Docker image. And I'm going to define a container name as Dragonfly, and the host name is going to be Dragonfly. We need the privileged flag as true to install DragonflyDB container, and also we need to add memlock flag as -1. So this is a Linux property, ulimits.memlock. If you set it as -1, this will disable all the restrictions by the operating system to allocate memory to the database, right? So usually these kind of settings are set for the databases. So we need to also set this particular flag to be able to run the DragonflyDB Docker image. So the next property is going to be ports, and we are going to expose the port 6379. So this is the default port in which DragonflyDB will be running inside the container, and we will also be mapping the same port to the 6379 port of the local machine. So to be able to test if this configuration is working or not, I'm going to open the terminal, and in here first I need to update my shell, and once this is done I'm going to run docker compose up -d. So this will, if you're running this for the first time, the Docker container will, the Docker daemon will first try to pull this image from this URL, and then it will start the container. As I'm already downloaded the app or downloaded this image previously, it's right away went ahead and then created the container. So if you open the Docker dashboard, you can see that inside the chat app service, we have the DragonflyDB container, which is running on port 6379. So if I can also check the logs to see if everything is working fine or not. And you can see that the logs says that the DragonflyDB is started successfully on port 6379, right? So let's go back, and this is how you can install DragonflyDB on your machine using Docker. So after configuring the DragonflyDB, let's go back to our chat controller, and let's continue building the other endpoints. So we define the endpoint to send messages to the clients. And the next endpoint we are going to configure is to add the user to the application. So whenever the user is added to the chat, we need to also register them in our application. So let's go ahead and do that. So for this use case, I'm going to, similar to the previous use case, we are just going to add the message mapping annotation, and I'm going to call this endpoint as chat.addUser. And in here the method is going to be public chat message, and I'm going to name the method as add user. So this is going to take the payload as chat message, and in addition to that, we need to have access to an object called as simp message header accessor. So let's call this as header accessor, and using this header accessor we can get access to the WebSocket session. So what I'm going to do now is I'm going to first get username from the chat message object and add it to the WebSocket session, and then send the chat message back to the clients. So back to the clients with the message type as join. All we have to do is we have to get the username from the current chat message object and add it to the WebSocket session, and then send the chat message back to the clients so that the other clients will understand that there is a joint event which is triggered. For that, I'm going to first make use of header accessor .get session attributes .put, and in here I'm going to define a key called username, and inside here I'm going to add chat message .get username. Now I'm going to define the chat message .set message type as message type .join. So it's not .set message, but it should be set message type .join, and the message is going to be set message chat message .get username joined the chat, right? And lastly, we are going to add also the timestamp. That's going to be local date time .now .format date time formatter ISO local date time. After that, we can just add a log message. So to add the log message, I need to add the SLF4j annotation. So after adding the annotation, I'm going to type in log.info user joined, and I'm going to add the username of the current user. So after that, all we have to do is send the chat message back to the clients with message type as join. So as we already set the message type as join, so I'm going to just type in Redis template .convert and send. So the channel name is going to be the same channel as previous. So as the previous one, so it's going to be chat. So I'm just going to define the name as chat and send the chat message through the Redis template. And finally, I'm going to return the new chat message back to the client as a response. So this is how you usually register a user to a chat session. I'm just going to explain this whole thing one more time. So we are going to take the username from the chat message and add this username to the WebSocket session. And then we are going to construct a new chat message of type join and with a message. And then we are going to send this message to all the clients that are subscribed to our application, all the chat clients that are subscribed. And using Redis template, we will send this message to all the subscribed clients. So that's how you usually register a user to the application. So whenever a new user is added to the chat, you will see a message, the username joined the chat. So the next step is to display a message whenever a user left the chat, right? So for that, we need to create a listener. Inside the listener package, I'm going to create a new class called as WebsocketEvent Listener. And here I'm going to add the component annotation, the required args annotation, and the SLF4j annotation to provide logging capabilities. And in here, I'm going to inject the Redis template class. So I'm going to type in private final Redis template string and object. And this is going to be called as Redis template. So as we are going to listen to the incoming, listen to the session disconnected event. So all I need to do is add the event listener and define public void handle WebSocket disconnect listener, right? And this method is going to take an object of type session disconnect event. And inside the session disconnect event, I am going to make use of the simp message header accessor dot wrap, and I'm going to define the message and I'm going to wrap it inside the simp message header accessor. So what this particular line is doing is getting the message from the session disconnect event and creating a header accessor object. So from this header accessor object, we need this header accessor object because we need to get the username. So in the previous method, we saw that we are setting the username inside the session. So to retrieve that username, we need access to this header accessor inside this method, right? So what I'm going to do now is header accessor dot get session attributes dot get, and I'm going to get a value for the key username. And let's define this into a new variable called username. And as this is a type of object, I need to cast this to a type of string. And let's define this username as a type called string. And if the username is not equals null, so I am going to construct the chat message. And inside the chat message, I'm going to set the message type as message type dot leave and set the username as username, set the message as username left the chat. And also I'm going to add some logging information, user disconnected, and let's add the username here, username. And finally, we have to send this event back to all the clients so that this event is broadcasted to all the other chat messages. So I'm going to type in Redis template dot convert and send, and the channel name is going to be chat followed by the chat message that needs to be broadcasted. So all you need to do is just write this piece of code so that it defines an event listener. So whenever a user is disconnected from a chat session, that message will be sent back to all the clients, all the chat clients. So that's the backend part we need to write to define a simple chat app, a group chat application. So now let's concentrate on the code for the front end. So as I mentioned before, you are just going to use plain HTML and Thymeleaf for this for the front end. So to get access to the front end code, you can refer to the GitHub repository, to this GitHub repository, Spring Boot WebSocket Chat PubSub repository. I'm going to add the link in the description section of this video. So let's go to the source main resources folder, and inside the static folder, we'll just click on this index.html and copy the whole code from here and we are going to create the same file inside our IDE. Under the resources folder, I'm going to create a new directory called as static, and inside the static directory, I'm going to create a new file called as index.html, and I'm just going to paste all this code from the GitHub repository to this particular file. So I'm not going to spend much time explaining the code because this is a tutorial that is completely geared towards Spring Boot and the backend side of things. So now after adding this file, now let's go ahead and try to run the application. So as we already have the DragonflyDB database started already through a Docker container, I'm going to go to the chat application, and I'm going to, so you can see the logs that application is started on port 8080, and we also see some logs from the simple broker message handler. So this is something internal to the Spring Boot, which is confirming the status that the broker is also started. So now let's go to the browser, and I've opened the URL localhost 8080, and then you are greeted with a very simple looking page which is asking for the username. So I'm going to type in my name, Sai, and I'm going to click on the start chatting button, and you can already see that there is a status message that Sai joined the chat. And now if I type in a message, hello everyone, so there is no one inside the chat room, but you can see that my message is displayed. It's reached the server, and then it's displayed now on the browser. So now let's copy this, and I'm going to create a new window, and I'm going to enter a new name called as test, and I'm going to click on start chatting. So this will add the test user into the group chat session, and I'm going to type in the message hi. And if I go back to the first tab, you can see that the test joined the status message, test joined the chat, and you can also see the message from the test user. So let's do the same thing again in the new branch, in a new browser window, and this time I'm going to add the username as John and click on start chatting. And if I go back, you can see also the status message that John is also able to interact with us through the chat. So now let's add one other message. How are you guys? And if I go to the second tab, you can see the status message of John and also the messages from John and Sai. Let's come back to John here, the third browser window. I'm doing well. So this is the response from John. And of course, this message will also be displayed in the test user and also the my user window. So the demo we just saw is for the instance where you have only one server running and you have multiple clients connected to that server. But to test the architecture where you're using DragonflyDB as the queue, we need to run multiple server instances. So for that, we need to run multiple instances of our Spring Boot application. As we are not running on a cloud environment, I introduced a quick workaround so that we can run multiple instances of your application on your local machine. So for that, I'm going to open my project in IntelliJ, and I created two new profiles called as instance 1 and instance 2. So on the instance1.properties file, you have server.port variable set to 8081. So that means the application instance will run on new application instance will run on port 8081, and for instance 2, the new application instance will run on port 8082. So to run the multiple instances, make sure you run the chat application first. So I'm just going to restart the chat application, and you can see that it is running on instance 8081. And now I'm going to run a Maven command so it's Maven Spring Boot run, and I'm going to provide the argument springboot.run.profiles as instance 1. So this will start the build of the Spring Boot project, and it will run the application on port 8081. So if you just scroll to the right side, and you see that the application is running on port 8081. So likewise, if I do the same thing, if I run another command with now the Spring Boot run profiles value as instance 2, you can see that there is another process which started executing, and it started an application on port 8082. So now we have 3 instances of our chat application up and running. Now I'm going to open a incognito window, and I'm going to type in localhost 8080. So now the application is connected to the first instance. I'm going to type the username as Sai and start chatting. Now I'm going to copy this and open it in a new tab and open the URL localhost 8081, and I'm going to provide the username as instance1 here. So likewise, I'm going to create a new browser window, and I'm going to go to the URL localhost 8082. And here I'm going to call this as instance3. So if I go back to the first browser window, you can see that the status message of instance1 and instance3 are also displayed here. So let me type in the message, hello everyone, and this message should be broadcasted now to instance2, instance1, and also instance3. So you can see that it is working. Let's reply back from instance3, hi Sai, and this message is also displayed in instance1. So I'm going to type in here, hi everyone. So let's go to the first browser window, and here you can see that the message is also displayed in the first browser window. So till now you learned how to use the PubSub messaging feature of DragonflyDB. So the one thing you need to understand about PubSub mechanism is it does not provide any persistence or delivery guarantees for the messages. So that means if the consumer is not available and if there is new message coming into the DragonflyDB, then that message is lost and it cannot be and will not reach the consumer anymore. And if your application has strict delivery guarantee requirements, then you can make use of the stream data structure from DragonflyDB. So you can read more about the stream data structure in the DragonflyDB documentation website. I will link this in the description section. But if you want to use this in the Spring Boot ecosystem, of course, as I mentioned before, as DragonflyDB is fully compatible with the Redis libraries, we can make use of the Spring Data Redis library, and we can make use of the Redis stream supports from Spring Data Redis to implement the streams functionality. If you want to use DragonflyDB in other projects, in other programming languages, keep in mind that DragonflyDB integrates with the BullMQ messaging system, which is useful. It is used in the Node.js ecosystem. So BullMQ is a popular background job processing library for Node.js that provides robust task scheduling capabilities. If you want to know more about how to integrate DragonflyDB with BullMQ in your Node.js projects, do check out the blog post which is linked in the description section. And other than that, DragonflyDB also provides integration with Sidekick, which is a background job processing library used for Ruby projects. Again, you can find the blog post in the description section if at all you want to use DragonflyDB, and together with Sidekick, you can refer to this blog post.